Have you ever stopped to think about how you can jump? I mean, with one little push, you can defy the gravitational pull of the entire planet beneath your feet. So what if the reason isn't that you're strong, but that gravity is incredibly, unbelievably weak? And what if it's weak because most of its power is leaking into other dimensions? Okay, let's get into this.
This right here is one of the biggest unsolved mysteries in all of physics. It's called the hierarchy problem. See, there are four fundamental forces that run the universe, but one of them is just a total oddball. Gravity, the force that holds galaxies together, is literally trillions and trillions of times weaker than the other forces. The big question is, why?
I mean, really think about this for a second. A tiny little fridge magnet can hold up a piece of paper against the gravitational pull of a planet that has a mass of 6 sextillion tons. That's not just a small difference in strength, it's a colossal cosmic imbalance that physicists have been trying to explain for decades. It just doesn't make sense.
To solve this puzzle, some of the most mind-bending theories out there, like M-theory, propose a solution that sounds like it's straight out of science fiction. Gravity isn't actually weak at all. It just seems weak to us, because its influence is spread out over way more dimensions than the ones we can see.
This idea is called brain world theory. Picture our entire universe, every star, every galaxy, you, me, all of it, as being confined to a thin, four-dimensional membrane, or brain. And this brain, our reality, is just floating in a much larger, higher-dimensional space called the bulk. Kind of like a single slice of bread floating inside an infinite loaf.
So here's the crucial part. Just like photons carry the electromagnetic force, a hypothetical particle called the graviton is thought to carry gravity. Now, string theory suggests that all the other particles, electrons, quarks, you name it, are like open strings with their ends stuck to our brain. They're locked in with us. But the graviton is different. It's a closed loop, a tiny little circle, which means it's free to travel anywhere, including right off our brain and into the bulk.
And boom, that explains everything. The other forces feel strong because all their energy is concentrated right here, in our 4D brain. But gravity's energy, carried by those free-roaming gravitons, gets diluted. It spreads out across all 11 dimensions of the bulk. What we feel here is just a tiny fraction of its true strength.
Now that is a fantastic theory, but is it science or just some cool sci-fi idea? To find out, we need evidence. And the best place on Earth to hunt for extra dimensions is the Large Hadron Collider at CERN. The process is conceptually pretty simple, but technologically it's just staggering. Scientists smash particles together at unbelievable speeds, creating these tiny fireballs of pure energy. In these collisions, for a split second, new and exotic particles can pop into existence. The job of giant detectors, like ATLAS and CMS, is to act like detectives at a cosmic crime scene, sifting through the debris for clues.
In this high-energy investigation, physicists are looking for two very specific pieces of evidence, two smoking guns that could point to the existence of these hidden dimensions.
The first clue is a family of echo particles. The theory predicts that if extra dimensions exist, our standard particles should have much heavier cousins, called Kaluza-Klein states. They're basically the same particle, but with some of their energy vibrating into the extra dimension, which makes them appear way more massive to us. Finding one would be like hearing a familiar note played in a much, much deeper octave, a clear sign of a bigger instrument.
The second clue is a little more subtle. It's the evidence of a perfect escape. When particles collide, energy and momentum have to be conserved. What goes in must come out. But if a collision creates a graviton, it could just blink out of our brain and vanish into the bulk, taking its energy with it. The detectors would see an impossible imbalance, energy that just disappeared. This missing energy would be the ghostly footprint of a graviton that fled the scene.
So after years of collisions and analyzing petabytes of data, what have these cosmic detectives actually found? Have we caught a glimpse of another dimension?
Well, the data from the latest run of the LHC is in. Both the ATLAS and CMS experiments have pushed the search to incredible new energy levels. They've looked for heavy particles, missing energy, even tiny microscopic black holes. And the result? Nothing. Zilch. Not a single statistically significant sign of anything beyond what we already know. This quote from an ATLAS experiment summary puts it pretty bluntly. It's a short, simple answer to an incredibly complex question. After all this searching, we have found zero definitive proof for these extra dimensions. Yet.
But in science, not yet is not a failure. It's actually crucial data,
Every search that comes up empty tells us where the extra dimensions aren't. It rules out certain energies and sizes, forcing theorists to refine their models. It's like looking for your lost keys in a dark field. Every patch of ground you search and find empty narrows down where they have to be.
So, while we wait for that experimental proof, let's just explore the absolutely profound implications here. I mean, what does it mean for us, for our existence, if this theory turns out to be true?
The first massive shift in thinking is this: space and time, the very bedrock of our reality, might not be fundamental at all. Instead, they could just be emergent properties of a more complex reality underneath, the reality of strings and brains in 11 dimensions. Our universe isn't the stage, it's just one of the actors on it.
And this leads to a powerful and pretty humbling analogy. If this is right, then everything we know, everything we see and feel and experience in our 4 dimensions, it might be nothing more than a projection, a shadow cast onto our brain from a richer, more complex, higher dimensional reality that's fundamentally inaccessible to us.
Which leaves us with this final, tantalizing question. If the world we inhabit is just one thin slice of existence, a fragile brain floating in a vast cosmic bulk, then what else is out there? What other brains, what other universes with entirely different laws of physics might be floating just a millimeter away, forever hidden in a dimension we can never, ever touch? The search for that answer continues.